Are you able to see my screen? Are you able to see my screen? Hello.
Yes, sir.
Are you able to see my screen?
Yes, sir. It is shared.
So now we can start.
Okay.
So before start today's problem solving classes, so brief introduction about me. So I am Pobir Maiti, a PhD student from Aizer Mohali. So I am TA of this course Polymer Concept of What is Uses and Sustainability. Course instructor was Professor Abhijit Pidar Deshpande. So earlier classes I have talked about some mathematical problem related condensation polymerizations, and lastly I have told about that liquid crystalline polymer. And next class onwards I tell that how we can characterize those polymers like normal polymer or liquid crystalline polymer one. So how we can characterize a polymer, so how we can identify that what is polymer and what is monomer like this. So if you want to go to the characterization of polymers, so the first characterization of the polymer may be that their chemical structure information. So if you get some chemical or structural information of the polymer, so what we have to do, we can do some one. So we can do the characterization technique such as UV visible study or FTIR study or NMR study. So from UV visible study, so what we can get? So if there will be some aromatic group present in our molecule, so from UV visible study, we know that for the any aromatic group or anything, so we can get that absorption spectra of this molecule into the UV instrument. So if you get that absorption spectra, so from there we can identify that there will be aromatic or aliphatic. If there will be aliphatic group, so then that absorption region will be very low. If there will be aromatic group, maybe this will coming around 500, 600 like. So from this we can identify that in our polymer system there will be aromatic or aliphatic group. And then the another technique was the FTIR spectroscopy. In IR spectroscopy, what we can do, we can identify the functional group present in our polymer system or in a monomer system. Because in IR, so every functional group have their every stretching and bending frequency. So if I show the carbonyl, so if you make some like acid, so if you go to this polyester synthesis, so polyester synthesis is mainly nothing about that from a acid and there will be some alcohol. So from acid and alcohol we are getting the ester peak polyester. So if I add acid and alcohol of different, there will be different alkyl group like R. So from here we getting the ester. So if you do that IR spectroscopy of this like acid one and alcohol one, and then we can do the IR spectroscopy of polymer. So for all of the cases we are getting the different stretching frequency of this carbonyl bond, because this carbonyl stretching frequency are depend on the what functional group attached to that side chain. For the acid cases, maybe these are in conjugation, so that IR stretching frequency is different. For OH, the IR frequency is coming around 3000 or 2500 to 3000. This is coming around 1780, 1700 to 1800. And for ester, that acid peak and the ester peak, we can identify from that IR spectroscopy. So from IR spectroscopy, we can identify that in our polymer system, there will be no monomer are present, or we can tell that our monomer are converted into the polymer. So there are another technique that we call NMR spectroscopy. From NMR spectroscopy, we can identify the whole the polymer chain, what type of bonds are involved in the polymer chain. Like if we do this polyester, so we get some for this ester bond making, so that earlier maybe that ROH what we are get from the NMR. So from NMR we are getting that ppm value. So maybe this earlier that ppm value of this alcohol is different. After polymerization, this ppm value is different. So here this one is that FTIR spectroscopy, how we are giving a sample here, and with that passing a monochromatic light, and from the instrument we are getting spectra transmitted spectra. So from there we can identify that what in the stage of our polymer. From NMR also, so here that from NMR you know that our NMR should be active for those molecules which have some odd electrons. So odd electron only active in the NMR. So for this we can do that 1H proton NMR spectra or 13C proton NMR spectra like this. So this the instrument where we put the NMR tube, and here the detector, we get the spectra here. So if you go some real analysis like synthesis, how we can identify our polymer monomer to polymer. Like I have example this, you know that amino acid. So from that amino acid there will be different type of amino acid. This amino acid is called as that proline. And from this proline amino acid, so proline structure will be like this. So if you're going for any amino acid, so there will be some functional group, and in amino acid their functional group are, there will be some amine and acid group. So this will be the structure of proline. So here I am given one example like ring opening polymerization of proline. So from this proline we are making some monomer. So this our monomer to get that polyproline. So this monomer, which are the characteristic of IR spectra of that 1780 and 1850 centimeter inverse. But when we are polymerizing it by some initiator, so this is our initiator, and this after the polymerization, these are our repeating unit. So if you polymerize this, so then we get that our monomers, the monomer there will be 2 carbonyl, but after polymerization we are getting 1 carbonyl. Also these carbonyl are different. So from this carbonyl, so earlier this will come at 1780 and 1850, but after polymerization it is come 1650. So from this after polymerizations that spectra will be different. So from there we can isolate that our polymer and monomer. And if you go to that how it will be polymerized, how the ring opening polymerization will be done, like any amine system if we add here, which are amine are act as a nucleophile. So if any nucleophile we are giving in this system, so this is our monomer. So nucleophile has that lone pair, so it will be attack in this carbonyl, and from here it will becomes and our CO2 will be liberated. So it will be from here it will be liberated as CO2, and we are getting N minus, then again N minus will act another monomer, and it will be going on up to that all monomer are not consumed from the system. So this is an example of ring opening polymerization. So here we break this ring to get our polymer. So from this that IR spectroscopy we can identify that functional group and how the functional group are changes from the monomer to polymer. So from the NMR, so if you go to the NMR study, so they like this one is the monomer NMR spectra. So from NMR, so if there will be single molecule, so we are getting the sharp peak of the individual hydrogen. But when do the polymerization, so for polymerization, so there will be 45 repeating unit present in that. There is 45 monomer unit present in the polymer system. There is 45 repeating unit of this proline. So now the peak becomes broad. So earlier when we are doing the NMR spectrum of monomer, so the peak will be like this. This will be sharp peak. But after getting polymer, so we are getting this are the broad peak. And from where we can calculate that how much repeating unit add into the polymer system. So how we can calculate that how much repeating unit. So if you go that the polymer, so polymer have some initiator unit, so this will be our initiator. So this will call that benzylamine, or then this are the monomer, so it convert into the polymer. So the initiator peaks coming here around that 5, and after that polymerization we get this NMR spectra of that polymer. So if you consider this position, there will be one hydrogen. So if we do this NMR spectra and we integrate this peak as there is a total 5 photon in this benzene. So total 5 photon of benzene, and from that from 1 photon of we are getting around 41 or 42 arounds. So from one initiator we are getting the 42 of this hydrogen. So this will be our monomer will be 42 times repeated in the polymer chain. So from where we can calculate that degree of polymerization or how much repeating unit add into our polymer system we can calculate. And if you know that how much the repeating unit, then also we can calculate the molecular weight, because we know that molecular weight will be the weight of one repeating unit into that how much repeating unit are present in the system. So here will be 42, and we know that how much weight of this repeating unit, so we can calculate the molecular weight also. So there will be other technique for polymerization, polymer characterization. Like if we are going to characterize the molecular weight and the distribution, there will be technique like GPC, gel permeation chromatography technique, where here we do that we run the sample, and there will be some column into that in between the instrument, and from their column there will be some pore are present. So if we pass our polymer sample in from this column, so when there will be a higher molecular weight, so they are comes out easily, but when there will be lower molecular weight, so their hydrodynamic volume is lower, so this goes into this pore, so it will take time to comes out from the system. So here we can get a plot from that, we call that Ri, at the refractive index versus retention time. So if you plot this Ri versus retention time, so what we can get that when there will be lower molecular weight, so it will be takes times. When there will be higher molecular weight, it will be takes lower time. Like if you, this will becomes 5 minutes, and it will be like 10 minutes and so on. So when there will be higher molecular weight, it comes easily, and when there will be lower molecular weight, it takes times to there. So from there we can calibrate this instrument by that known polymer molecular weight. Then we run our sample and we will get plot of like this. Then we can identify the how much molecular weight of this polymer of unknown polymer solution. There will be some viscosity measurement. So from the viscosity measurement we can know about the polymer molecular weight, because we know that when we increase the polymer molecular weight, we increase the viscosity of this polymer solution. There will be another technique like thermal analysis. So from thermal analysis there will be for when we goes for that small molecule. So for small molecule there will be give a sharp melting temperature, but polymer for this larger molecule we cannot, we don't get any sharp melting temperature. So there will be when we heating a polymer sample from the temperature, so if I that will be slight change in this heat flow. So this is for the glass transition temperature. Earlier also told about the glass transition temperature is a temperature before that our polymer is become brittle, and above that polymer becomes soft. And if this one the crystalline temperature, so crystalline temperature like when we some crystallization, so it takes, it's because after crystallization the material get more stable, so it's release it. So for this reason this peak will be like this. And when there will be melting temperature, that is the Tm, so we it will be absorbed heat by the system, that is we getting the endothermic curve. So from that we can identify that Tg and melting temperature of our polymer. So what we do that in DSC instrument, so like in DSC there will be two pan, one is our reference pan and another is our sample pan. So in sample pan we add our polymer sample, and in reference pan it will be empty. And when we, so there will be given this, we put those two pan into that instrument. So when we heating this, so that when there will be no polymer, so only air, so the heat absorbed by this reference pan will be different from the heat absorbed by this polymer pan. So from there we can get a plot, get a curve of this like this, heat capacity versus temperature. So from here we can calculate that polymer melting temperature or Tg. So why this Tg and melting temperature are important? Because if you want to like your, if you want to use a polymer or any rubber, if you want to use this polymer sample in a cold area like Russia or anything like there, and you want to use this polymer in like our country where the temperature is around above 25 degrees centigrade, and if you use this polymer like where the temperature is below 5 degrees centigrade, and if you don't know about the Tg of this polymer, so when you like if your Tg is 10 degrees centigrade, so you can use this polymer for their application in India. But when your Tg is 10 degrees centigrade and you want to use this polymer it's below 5 degrees centigrade, then you get the brittle behavior of this so you cannot use this polymer there. So every application needs that polymer, that what temperature, this is the applicable temperature of this polymer. So like this, an example of polyethylene terephthalate, where the Tg of this polymer is coming around 75 degrees centigrade, and this is the melting temperature is coming around 200 degrees centigrade. There will be another technique, the thermogravimetric analysis. So thermogravimetry analysis is nothing but we are heating the sample and we are calculate how much weight loss of the polymer sample. So if your polymer is the absorb more heat, that is that it can withstand more thermal behavior, like when we are, like as compared to polyethylene, we are going to any polycarbonate system. So polycarbonate system are going to absorb more heat as compared to polyethylene. So from here, so if you plot a percentage of weight versus temperature, like this example polystyrene and polyethylene terephthalate. So polyethylene terephthalate like dotted line. So it's showing the polyethylene terephthalate can withstand more heat as compared to the polystyrene, because as you know the polyethylene terephthalate group have that terephthalic acid into the monomer chain, so that can give them more thermal stability of this polymer. So if also we can understand if there will be like this for the single polymer system. So if you are going to that polymer blend or polymer composite like system, so if you have polymer composite, you tell, so polymer composite is present of polymers and some reinforcing material. So like polymers which have the degradation temperature is around 400-500 degrees centigrade, but when we go that reinforcing material like inorganic material, that degradation temperature may be higher, 800-900 degrees centigrade. So from there we can get the idea about that what reinforcing material are present in our polymer system. The another techniques of characterization technique is the mechanical property. So mechanical property is like that we can get the tensile strength, impact strength, hardness, testing, etc. Tensile strength, that is the how much weight that our polymer can sustain before it break. Impact testing is like that sudden how much weight can polymer can take, and hardness is that resistance to indentation, that is how much surface was the hard, like for any surface indentation. So if you plot, so from that tensile strength, so like this the instrument where we can measure the tensile strength. So before that we measure the tensile strength, we make the dumbbell shape of our polymer, then we add this polymer here, and from this instrument we applied load and we strain and extension. If we applied load in the above two directions, so the extension of the polymer will be happen. So this will tell that from there we can get a plot stress versus strain. So from this, that first one, that the elastic deformation, so that elastic deformation is tells about that how much weight, how much stress our polymer can sustain, that there will be nothing change in that permanent changes in the total strain. So like when there will be elastic deformation, so if we stress this and if you remove that stress, so it will be come back into a position immediately. So this will be our elastic deformations. But uniform plastic deformation will be like this, when we give that weight stress into the polymer system, so there will be time dependent recovery of this polymer system, so it will take times to recover that original shape. So for this this region is plastic deformations. But if there will be a position like that when there will be no chance to come back their original position, So that will be non-uniform plastic deformation like necking, or there will be fracture. So from here we can calculate, we can know about that how much weight can sustain of our polymer, how much load bearing capacity of our polymer system. That will be mainly important for when you carrying some load, like in a plastic you carrying some load. So how much load this plastic can absorb. So from there we can understand, before that application we can understand that how much load it can sustain. So from there also we can also know about that how what is the property of this material. Like this, if we from the stress strain curve, if we're getting this material, like if we apply load, so if we apply load, so if we apply load in the polymer system, so if after adding load, and this chest and scarp is steep and it will be break here. So these are the property of hard and brittle material, because it cannot get any toughness property. But when we apply load, that the strain will be very low and it will sustain more load. It will be behavior of like hard and strong material, so like a thermoset material, where their thermoset materials is nothing like that. There will be some cross linking present into that polymers. So for this there will be not change in their shape. But when we goes for that typical thermoplastic material, so they may be behave like as a heart, like this can absorb load a certain, but this also can a tap, so this can go to the plastic deformation. So you have to go for the soft and tapped material like this, that stress and scarp will be like this. So it will be lower stress will be needed for the getting more strain, and will be we are getting more toughness area. So from there we can identify that for the brittle polymer maybe like this, there will be stress strains will be very sharp. For the thermoplastic polymers we are getting stress strains and plastic deformation. For elastomer, we know that for the elastomers which are needed less stress to getting the extension of this of rubber, so the stress tense curve will be like this. Maybe this are comes into your gate exam also. There when they can give that some specific curve and told about the how what is the property of this material, and how could we can identify this material like this. What is the rubber? What is thermoplastic? What is hard or brittle material like this. Then another characterization technique is the surface characterization. So surface characterization is like this. So what are present into the surface of the material and how the surface is look like. So from there we can know about that how much. So this is an example of the surface of porous polymer membrane. So you can identify this the porous structure of the polymers. So this we can get that scanning electron microscope. So where the scanning electrons microscope is nothing like that, like this also the microscope, but the resolution of this microscope is very high, so we can see that the nanometer region or micrometer region. But normal microscope maybe that go to the millimeter region. But the scanning electrons microscope, there will be used some electron beam to get the picture of our polymer sample. So there we can identify that our polymers, how the surfaces look like, and in the surface if there will be, if we told about the composite material and how this composite reinforcing material are mm, placed into the surface of the our polymer system, it will be distributed uniformly or it will be aggregated like this. We can all of this information we can get from this SEM or AFM analysis, atomic force microscopy. Why these techniques are important? So if you are going to some nanocomposite material, we have prepared some nanocomposite material, and we know that if the material, the nanocomposites are not aggregate throughout the surface, it will be distributed over the surface, then the total load bearing capacity will be more high. And if will they aggregated in some region, but this region will be no nanocomposite, so maybe that load bearing capacity of this overall material are not so much. So and this like nanocomposite are can application in that aerospace engineering, whether we can get that lower weight materials with the high load bearing capacity or high toughness material, high strength material. So for that we have to know that how these surfaces look like. So from there we can get an idea about that property of this material. So like this AFM study, so like you saw in the picture, so there will be exploited clay. That is, exploited clay means that clay is the separated, it will be separated, this region separated. But non-exploited clay, like this clay are aggregated system, so it will be aggregate like this. And this one the polyethylene glycol, where that no clay are present. So from there we can get an idea about that properties of the material also. And there will be some other characterization technique like rheological properties. So rheological properties are important when you want to process this polymer sample. So when we want to process the polymer sample, so you have to know that how much shear stress will be happened into your instrument, and your instrument can take much about that much shear stress or not. Because the polymer, when we have made this polymer, so the polymers have become viscous. And so if you're making any application of this material, so you have to give some shape of this polymer. So if you are going to shape of this polymer, so you have to making the melt of this polymer. So making melt, we can heating this polymer and we can melt it. So after heating this material, how the polymer will be behave like this, so that will give our rheometry rheometry instrument. So how the rheological properties of this polymer. There will be some properties like chemical properties. Chemical properties will be that chemical resistance, that in where this polymer will be applicable. Like if you go some area where that pH of our water system will be high, or if you go into the use this polymer in that salty water or normal water, so there will be change of pH, and the behavior, the chemicals present in the environments are different. So is this our polymer can sustain this chemical environment? So we can test this polymer, that what the chemical resistance of the polymer. Also we can change the hydrophobicity and hydrophilicity of the polymer, so that are very much important of that polymer. Because when you want to synthesize any polymer, or if you want to application of polymers, so you need, for synthesize you need to solubilize this polymer in a system. So when you want to choose a solvents, and you know the behavior of the polymers, that what units, chemical unit presence into the polymer system, so that will give that hydrophilicity or hydrophobicity in the polymer chain. Like if there will be some amide group present in the polymer system, so maybe they are behave like hydrophilic. But for polyethylene type, polypropylene type, where there will be no hydrophilic group present, so they are completely hydrophobic. So the choosing of solvent for different medium will be different. And there will be other properties, like when you apply this polymer material in insulating, so insulating application, so you must know about the dielectric constant of this material. Or when you want to this apply this material for optical properties or like this. So you want to know that optical properties of this polymer, like how much transparency, refracting index, all of this. There will be another technique like UV resist environmental testing. So where we are getting the UV resistance or weathering test. UV resistance because if you want to use our polymers, if there will be UV degradation happen by like you want to use the polyethylene system. So polyethylene nothing but there will be single bond into the polymer system, and if there will be some unsaturation present in our polymer system like this, any double bond present in our polymer system. So if there will be any double bond like a rubber what apply in that tire application, so there will be some unsaturation in the polymer bond. So if there will be some unsaturation in the polymer bond, so like when you UV radiated this, so this bond can break and they can become a radical. So if they are making radical, so our polymer degradation will be start. So if the polymer degradation will be start, so before apply this material, so like this rubber are apply in the tire application. So before apply this material, we want to know that how much, because this tire are apply in that outside road or sunlight. So we want to know that how much UV radiation or how much cycle it can withstand this UV radiation before that degradation. Or weathering test we can do that, we can say how much water it can absorb or like this in different weathering condition, how it can sustain. There will be another characterization technique like analytical techniques, like that we are getting idea about that crystallinity of polymer. If you want to know the crystallinity of the polymer, so you can do the XRD. So from XRD, so we are getting the plot of 2 theta versus intensity. So from that plot we can get if there will be sharp region we are getting, so our polymer will be like crystalline with crystalline type, and if you're getting the crystalline type, the behavior of the polymer will be different as compared to the if you're going for the amorphous type of polymer. And there will be another technique to getting the idea about what are chemical species are present in the like polymer system, what are the carbon, nitrogen, oxygen, what are the present elements are present. So we can do the X-ray photo electron spectroscopy. So from here we can get that how much carbon percentage are present, how much nitrogen percentage present in our polymer system. Like this, you know about that ISRO make that they sent their that Chandrayaan 3 in that lunar mission in that moon. So there will be this technique are used, that XPS. So the what type of materials are present in that moon surface. So from that XPS we can get the idea about what are elements and what elements are can present in the moon, if there will be any water system. So then we can get the hydrogen, oxygen, or if there will be some carbon percentage is increased or not. Like this we can get all about that elemental study. And for so like that XRD, so XRD we are getting, if we told about that amorphous material, we can get like this type plot when there will be semi-crystalline. So our main all polymers are come, synthetic polymer are comes into the semi-crystalline region. So we get the plot from the XRD like this. The amorphous mainly that all the rubbers are come in this region amorphous. And highly crystalline material, if there will be highly crystalline we are get more sharp peak, and the XRD will be from XRD we are getting like this type of plot, intensity versus that 2 theta. From also we can get that peak intensity value. We can also get an idea about that what type of crystal are present in that polymer system, like the crystal will be FCC crystal or BCC crystal, or how this shape of this crystal we can get an idea from this XRD also. So now uh, I told about that polymer blend and polymer composite. So polymer blend is a combination of two polymers. So when you tells about the polymer blend, so when you give mixing of the two polymers, so they are mixed in the physical mixing, not a chemical mixing. So when they are physical mixing of these two polymers, so we are getting the polymer blend. So polymer blend, why you need polymer blends? For specific applications where we from this polymer have some certain property, this polymer have the certain property, but when you are mixing of these two polymers, maybe we are getting that properties combination of this two polymer. So we need the polymer blend to get application of our polymer. So there will be and if we're going to discuss about the polymer composite, so polymer composite, like that, when you know polymer system, we add some reinforcing material like some inorganic material we add into the polymer system. So if we add that reinforcing material in the polymer, so we call that composite. So in between polymer blend and polymer composite, polymer blend are mixing of two polymers, but the polymer composite are mixing of polymers with some filler or reinforcing material. The reinforcing material may be the glass fiber, like this. So they are used in a various type of application, like in aerospace or in automotive parts, civil engineering, sports equipment, like this. So next class onwards, so that polymer composites, that the properties of this polymer composite also depend on that how these reinforcing materials are present in the polymer systems. These are placed longitudinal or like vertical, horizontal, like this. So that will be depend. That will be give the properties of the polymer composite different, and then we can solve some problem like polymer composite, like what the modulus, like some gate question we can solve. So up to this, that you have any problem to understand anything?
No, sir.
Hello,
Hello.
understand all of this?
Yes, sir. I understand.
Okay. So that's the two in this course we are giving the two TA courses, like that. One courses in that one lady is taking, Kritika. She will more solve some gate problem or like this, and I also some problem. But if we're doing the same thing, that may be not good for all of you. So I am going to solve some other problems. You will also solve some other problem. So today's classes we are mainly discuss about that characterization technique or all of this polymer. And from the next class onwards, we are going to solve some problem, like some mathematical problem or some problem like from here also. So thanks for joining. Or if you have any doubt, you can tell.
Thank you, sir.
Or if someone miss the classes, you can mm, go to that YouTube. Maybe that NPTEL also share the YouTube link. So from there you can get when if you cannot solve some problem, and if we are solving this problem in classes, so from there we can get that. Okay. Or anything related of this course, any problem we can share, or you can tell. If you can, if I am not getting the answer, that classes I can solve this problem in next classes.
Okay, sir. Thank you.
Thank you for joining.